Hello students, how are you all? I hope you are doing absolutely fine. So welcome all of you at AriserTalent, and today we are going to discuss about some NTSE questions that are related to your stage 2 questions from your NTSE exam. And here we are discussing the chapter that is about the metals and non-metals we have. So let's begin with the question here. So the first question in this sequence we have: the following observations are given for 4 metals. So firstly, let us write the 4 metals here, and they are H, K, L and M. So I am writing here the 4 metals I have. So which metals are provided us? Metals are H, K, L and M. Now let us read the question step by step and try to follow and understand the every sequence of the question, because in question every word is very important. Metal H does not react with dilute HCl. It means this metal H is not reacting with HCl. Metal K reacts with warm water. So our metal K is reacting, but it is reacting with warm water. Metal L does not react with water but displaces H from its aqueous solution. It means it does not react with water but displacing H. So it is reacting and displacing H from its aqueous solution. Metal M reacts with cold water. Again, this metal is reacting, but it is reacting with cold water. Now, you have to arrange the correct decreasing order of reactivity of these metals. So, we have to arrange in the decreasing order of reactivity. We have to arrange these compounds in the decreasing order of reactivity. So, you can see here that this compound, that is our H, is not going to show any reaction with the dilute HCl. It means it is not reacting, so it will be on the last of the reactivity series. So I have to kept H here. Now this is not reacting with water but displacing H from its solution, so we will have to arrange L in the second position. Now we are left with 2 more compounds, that is K and M. Now you can see that the compound M is reacting with the cold water and K is reacting with the warm water. It means tendency of reacting M is greater than tendency of reacting with K. So I have to write K here and M here. Because this metal is even reacting with the cold water, it means its reactivity must be high. So the correct decreasing order will be M, K, L and H. And you can see that this metal is even reacting with cold water and it is not reacting with any of HCl, any water. So it will be placed in the last of the reactivity series. So what will be the correct option here? M, L, H and K, K, M, H and L, M, K, L and H, or L, H, K and M. So according to our solution, we can found that our option number 3 will be the correct answer for such kind of the question. So this question is from your topic, that is about the reactivity series. So you have to learn the reactivity series so you are able to answer such kind of the question that is asked in your exam. Now let us move to the next question we have. Now what is the next question saying? A metal occurs in nature as its ore, X. This is the ore. This ore, when heating with air, when we heat this ore in air, we will get a compound Y. This is the first statement we are given. Y when react with unreacted X. Again, when you are going to react Y with X, you will obtain that metal. Again, we will obtain that metal and you have to identify that metal from this series. Now, let's see the options here. The metal is found in its ore. So, here the Hg, mercury will not be an option. So, let us consider the options will be between copper, zinc and iron. And when you react that ore and again the oxide or sulfide of that ore, you will again get the metal. So, let us do the reactions with the second option, that is copper we have provided. So, solution I am doing here. Suppose copper is available in the form of CuTs. This is copper pyrites. This is copper pyrites and it is the ore of copper. Now, this is heated in air. Air means O2. If I am going to heat this Cu2s with O2, I will get a compound that is copper oxide along with SO2. This is the reaction that will going to take place here. Now, this compound is our X and this compound is our Y. Now, the question is saying that when you are reacting X and Y with each other, again you are getting metal here. So, let's do the reaction here. Now, when X and Y will react with each other, again we will get copper plus SO2. So, Cu2O is our compound Y. You can see here, this compound is our X and what we are obtaining here, we are obtaining the metal again here. So, it has found that the copper will be the correct answer. The copper will occur in its own ore form in the form of the copper pyrites. When copper pyrites, when reacting with air, it will give you copper oxide, and when you are going to react the copper sulfide and copper oxide, again we will obtain a metal that is copper. So, I can found here the option number B will be the correct answer for this question. Now, let us move to the next question in the sequence we have. Match list first position of the metal in the activity series and related reduction process and select the correct option using the code given below. So, let us see the match listing here. This is the list 1 and list 2 we are given. Now, in first list you are given the position of the metals, and in second list we have given a related reduction process that we are applying for that metals. Now, we have given the metal in the bottom of the series, top of the series, lower region of the series and the middle of the series. So, what four things we are provided here? We are provided with bottom, top, middle region and the lower region. So, these are the regions in which the position of the metals are placed in the reactivity series. Now, the metals which are placed in the bottom and the lower part of the reduction series that we are having, these metals are very less reactive. As we go from top to bottom, the reactivity will going to decrease. So, I can say that these are less reactive. This is less reactive and this is least reactive. Now, the metal which is present at the top of the activity series will be highly reactive. This will be highly reactive. And the metal which will be present in the middle of the activity series will be moderately reactive. This metal will be moderately reactive. Now, we have to choose the processes by which we can do the reduction of such kind of the processes. Now, the first process we are given the electrolysis. Now, Electrolysis is usually done for the metals which have the very high reactivity. It means high reactivity metals can be reduced only by performing the electrolysis. So, for the top metals, which process we will use? We will use electrolysis. Now, reduction by heating alone found in native state, reduction using carbon or some other reducing agent. Now, which metals are found in the native state? Native state metals are those metals which are found in the lower state, and for reducing by using heating alone and carbon alone, we can do that just by heating alone. We can get the moderately substance we have found in nature, and if you use the carbon as a reducing agent, you can separate the bottom substance you have in the reactivity series. So these are the options we have provided. You can see here. It means first one is electrolysis, second one is reduction by heating, then found in the native state, and you can see that we have B1. So again, when you see that if we are at the bottom part of the series, we will see that the lower bottom metals will be found in the native state. These are less reactive metals, so the less reactive metals can be separated only by heating alone, and the moderately reactive metal we will need carbon for their reduction. So this will be the sequence here. So let us see the slide first, which metal are provided at which series. So we can say that the top metals can be separated by electrolysis. When you want to do the reduction of the middle elements, we will use the carbon. It means the bottom part of the metals are found in native state, and if we want to separate the lower reactive metals, we will want to perform and we will do heating of such elements. Now the which element is matches to which element here, it means the metal which is found in the bottom of the series are found in the native state. Top metals can be separated by electrolysis. Lower region metal can be reduced just by heating alone, and the middle of the series we will use the carbon as a substitute. So which options I am getting here? A3, B1, C2 and D4. So this is the correct sequence I am obtaining here for all the options provided. So let us see options here. The options here are A3, C2, B1 and D4. So you can see that the option that correctly matches this sequence is our option number 3. So here the option number 3 will be the correct answer. Now let us move to the next question we have. Which of the following statement can help a chemistry student to predict the chemical properties of an element? Now we are provided with the 4 options here, and what things are needed for predicting the chemical nature of any chemical substance we are provided. So we have the list of the options here. Position of the element in the periodic table, atomic number of the element, number of shells in the atom, and number of electrons in the outermost shell. So if I am considering all these factors, the position of element in the periodic table is very important. Second, atomic number is equally important. What we are not needed is number of shells, because number of shells in an atom is nothing to do with the chemical property of the element, but the reactivity of the element, it means either it is electronegative, what will be its ionization enthalpy. These all factors will depend upon the number of electrons in the outermost shell. So I can say that the option number 1st, 2nd and 4th are the correct way to judge any element on the basis of its chemical properties. So which options are correct here? 1st, 2nd and 4th. So the correct option here matching will be option number 2, because number of shells will nothing to do with the chemical reactivity of an element. So option number 2 will be the correct solution we have. Now, let us move to the next question we have. A metal M of moderate reactivity is present as its sulfide. On heating in air, it converts into the oxide and Y gas is evolved. On heating Y and X, again the metal M is produced. This is the same question we have previously done, but this question is given in the statement form, so we are again doing that question. So, metal M is moderately reactive. It is present in the form of the ore and the ore is sulfide ore. When heating with air, when heating with O2, it is producing a compound Y and X. It will form oxide and the gas X. It will form the oxide and the gas produced is Y. This is our compound X. Now, when you are going to react Y with X, you will again get a metal. So, this question we have previously done, but this question now is given in the paragraph form. So, the answer here will be the copper sulfide and the copper oxide we have done previously. So, the copper which is present in the form of the copper pyrites, that is CuT2S. Now, if I am going to heat it within the presence of air, what I will get? I will get Cu2O plus SO2. So, what is the compound X? Compound X is our copper sulfide. And what is the name of the gas here? The gas here present will be SO2. Now, X converts into the into its oxide. It is converted into the oxide and gas evolved is Y here. Now, when X and Y will react with each other, this is our compound Y. This is our compound Y we are getting and the gas is evolved, that is SO2. Now, when we react X and Y, it means when you are going to react Cu2S plus Cu2O, again we will get the copper metal. Again we will get the copper metal. So, the compound here will be copper sulfide and cuprous oxide. So, the options are cuprous sulfide, cuprous oxide, cupric sulfide and cupric oxide, sodium sulfide, sodium oxide, calcium sulfide and calcium oxide. So, the substance present here will be cuprous sulfide and cuprous oxide, that we can obtaining here Cu2S and Cu2O. So, this is the solution of this question. You can copy it from here. So, we can proceed to our next question. Now, the next question in this sequence we have the metal M forming an oxide M2O3. Now, what is the oxide forming here? Oxide we have provided is M2O3. We have to determine the formula for nitride. We have to determine the formula for nitride. So, again what we are provided with? We are provided with M and O. This is the oxide of the metal. But if I am going to form the nitride, what I have to take here? I have to take N here. It means M is a metal and N is a nitride here. Now, you can see that valency of this metal M is 3 here. It means this metal is formed as, this is here -2 we have and 3 we have. So, on interchanging M2 and O3. This is the compound, we can see that in the basic chemistry we have formed. Now, this M will having a valency of +3. And what will be the case of nitride? In case of nitride, again we have the valency -3. Now, what will we do? We will again do the crisscrossing of the valencies. If I am doing the crisscrossing of the valencies, I am getting here M3 and 3. Now, you can see that this 3 will be cancelled by this 3 and the formula for the nitride will be Mn. It means from this oxide we have found the valency of a metal. The valency of the metal came out to be 3. And for making the nitride, again we have required a valency -3. So, M3 and 3 will be crossed by 3 and we will get the formula of the compound, that is Mn. Now, let's check the options here. M2 and 3, Mn M2N or M3N2. So the correct option will be Mn, that is option number 2. So this is how you can make the formula of the compounds. When any oxide is given, you can similarly form nitride and sulfides. Now, let us move to the next question. In this sequence we have the element that cannot be used as a reducing agent. So, we have to analyze the element which cannot be used as a reducing agent. So, let us check the option first. Carbon. Carbon is a very good reducing agent. Aluminium is also used as a reducing agent. Sulfur cannot be used as a reducing agent because we can't use anywhere sulfur as a reducing agent, because as we go from top to bottom in the reactivity series, we have found that sulfur is having no link with the reducing nature. So the correct option here will be sulfur, and sodium is actually used as a reducing agent. So you have to remember that sulfur is not used anywhere as a reducing agent. Now, let's move to the next question we have. An element X react with dilute H2SO4 as well as NaOH to produce the salt and hydrogen gas. Now, what the conclusions we can draw from here? X react with dilute H2SO4 and NaOH. Now, first draw the systematic arrangement for every sentence. We are provided element X. This is our element. Now, this is reacting with dilute H2SO4. And again this element is going to react with NaOH. Now, in both the reaction, you can see that what we are obtaining salt plus hydrogen gas. In the same sequence, we are obtaining salt plus hydrogen gas. Now, what conclusions we can draw from such points? X is electropositive element. Oxide of X will be basic in nature. Oxide of X is acidic in nature. X is an electronegative element. So, electropositive element when reacting with dilute H2SO4 is only liberating the hydrogen gas. So, we can conclude that statement first is correct. The oxide of X is basic in nature, acidic in nature, or it may be electronegative in nature. So, we can see here that the oxide X is forming is either basic in nature or acidic in nature because it is reacting with acid as well as base. So, these 2 points are again correct. But X is an electronegative element. We cannot say any point regarding this because X may be the electropositive element because it is reacting with acid as well as base. So, which options are correct here? So, I can found here that option number 1 will be the correct answer because it is satisfying all the 3 conditions. So, we can say that X will be acidic in X will be electropositive element and its oxide can be both acidic and basic in nature. Now, let us move to the next question in the sequence we have. The metal used to recover copper from an aqueous solution of copper sulfate. What you have provided here? You have provided here copper sulfate. Now, this copper sulfate, you have to extract copper from it. Now, you are provided with the elements sodium, silver, mercury and iron. Now, the elements which are on the top of the copper in the reactivity series will able to extract or to recover the copper from it, the copper sulfate solution. So, the element I can found here is only iron because these 2 elements, these 3 elements which are provided in the first 3 half of the question, you can see that this will not able to extract the copper because they are lying because the element which lie above the So the iron will have a capability to reduce the copper, and copper sulfate solution we will obtain the copper because it is lying in reactivity series before the copper. So the correct option here will be iron. Now let us move to the next question we have. This is the last question we have. So here are some of the questions that is related to your NTSE stage 2 we have dealt here. This is from the chapter metal and non-metals. Now many more type of the questions we will deal in our next lecture. Thank you so much and have a nice day.